They are misfits, arrogant rebels. They scorned conventional wisdom, and each conceived a radical new vision of the cosmos. Galileo Galilei, Isaac Newton, Albert Einstein, and Stephen Hawking have all had tumultuous lives, filled with great triumphs and humbling failures.
These are the people who would dare to challenge.
They often run into opposition, and they generally don't deal very well with that.
There was a kind of a demon within them that wouldn't let them do anything else.
It does take a strong ego to say, well, I can solve this. I can figure out some little piece of the universe.
Who were these brilliant rebels? And what secrets of their minds allowed them to think the unthinkable and reveal the beauty and strangeness of the universe? In 16th century Europe, life has a certainty that later generations can only envy. Everyone knows that the Earth is the center of the universe. But this reassuring vision is beginning to crack. And one of those who does the most to overturn it is a self-styled genius, Galileo Galilei.
Galileo, of course, was this cocky individual who had an attitude.
The sort of person who makes very close friends and who makes lots of enemies.
But he had a very sharp wit, a very sharp mind, and with that he was able to probe some of the deep mysteries of the universe.
This ambitious, overconfident scientist will remake the world, but pay a harsh price. Galileo is born in 1564 in Pisa, Italy. His father, a lute player, is well known for rejecting convention to create a new form of musical harmony. Galileo inherits his father's rebelliousness. At age 25, he becomes a professor of mathematics at the University of Pisa. But he'll grow scornful of his colleagues, who are still teaching the scientific theories of the Greek philosopher Aristotle, almost 2,000 years after his death.
We forget the fact that before Galileo, there really was no science as we know it. According to the Aristotelian philosophy, for example, objects moved and came to rest, not because of friction, but because they got tired. And objects fell to the ground, not because of gravity, but because they longed to be united with the earth.
To Galileo, such explanations seem absurd. These grand personages who set out to discover the great truth and never quite find it give me a pain, he later writes. They can't find it because they're always looking in the wrong place. Now, Galileo is about to shatter thousands of years of belief. His intuition tells him that objects move, not because of desires, but because of deep mathematical laws. And his unthinkable step is to find them through experiments, something few people have done before. He begins by studying falling bodies. Physicist Stephen Hawking.
Galileo pointed out that simple observations, like dropping weights from a height, show things do not work the way the ancient Greeks said. This must have been seen by many people, but they had put it down to imperfect observations.
For the first time ever, Galileo begins to work out basic laws of motion, such as how speed is determined by time and acceleration.
It was one of the geniuses of Galileo to slow down the acceleration of gravity. He got an inclined plane and had a ball roll down the plane, and then you could see with your own eyes the fact that an object speeded up as it went down. So he introduced the concept of acceleration.
To us, that seems so obvious and logical. That was a major mathematical breakthrough to understand motion in those terms.
For his role as the first experimenter, Albert Einstein will later call him the father of modern physics. Galileo has pioneered the path that Newton and Einstein will follow. The search for mathematical laws that lie behind all motion. But progress is slow. Only at the end of his life will they finally be published. At age 45, Galileo is still a poorly paid mathematician. But ambitiousness and arrogance will soon catapult him to fame and be his undoing. In 1609, Galileo hears rumors of a toy-like spyglass that makes distant objects appear near. Resolving to capitalize on it, he quickly learns to grind lenses. Within a few weeks, he arrives in Venice with a telescope he champions as his own invention. He impresses Venice's navy so much that officials double his salary.
Galileo did not bother to tell them that this was an instrument that was being exhibited and sold in many other places. There was considerable chagrin when they discovered that, in fact, this was not Galileo's unique invention. Well, what can you say? He was obviously being a good businessman there.
To the free-thinking Galileo, the telescope also offers an opportunity to ask questions few others dare. 60 years earlier, the astronomer Copernicus proposed the radical idea that the Earth revolves around the Sun. But Copernicus had little evidence for his theory, and it contradicts passages in the Bible. In the time of the Inquisition, such speculation treads close to heresy. But Galileo is unfazed. He is the first astronomer to train a telescope on the heavens. And he sees the universe as never before.
He was thrilled by the fact that this telescope is opening whole worlds. He draws pictures and diagrams, and he couldn't draw fast enough.
Galileo works feverishly night after night, and he makes a startling find. He discovers 4 moons orbiting Jupiter. Galileo's evidence that not all objects orbit the Earth lends strong support to the theory that the Earth itself could revolve around the Sun. But contradicting the Bible is theological dynamite. For those who cast doubt on his new theories, Galileo has no patience. He's seen the universe in a new way with his own eyes. How can I do this and not be merely wasting my time, he writes, when those peripatetics who must be convinced show themselves incapable of following even the simplest and easiest of arguments.
Galileo used his cutting wit to cut people down, and that didn't necessarily win him a lot of friends.
In 1615, at age 51, Galileo goes to Rome to argue his case. It may be his greatest mistake. the Church orders him to cease teaching that the Earth orbits the Sun. But Galileo pushes his luck. 9 years later, he asks to state his case again. This time, a new pope is a personal friend, and Galileo wins permission to write a book. Ever scornful of opponents, Galileo writes a dialogue and places arguments for the two sides in the mouths of characters who are thinly disguised.
When he wrote his books, it was very clear who was the smart one, who was the stand-in for Galileo, while the Aristotelians come out as the fools.
In 1633, Galileo is arrested by the Inquisition. The Church accuses him of heresy. But perhaps the real reason that Galileo is brought to trial is that he has gone too far in his efforts to persuade. Galileo has put one of the Pope's favorite arguments into the mouth of a foolish character in his dialogue.
The Pope was told by people around him that Galileo had tried in the book to make the Pope look a fool. And it was his personal decision to prosecute Galileo to the hilt and have him in house arrest for the rest of his life. It was not really a church decision. It was the Pope's personal decision out of solid anger toward a friend.
Galileo expects a simple compromise. Instead, he is threatened with torture. Bowing to the inevitable, he falls to his knees and recants. For his last 8 years, Galileo lives under house arrest, a broken man. He will gain immortal fame for championing the view that the Earth moves around the Sun. But to the scientists who succeed him, his greatest achievement is different. In his final years, he writes a book that completes the work that he began while young. He shows how it is possible to use mathematics to analyze motion. Ironically, the year Galileo dies, a boy is born 800 miles away who will bring Galileo's ideas to completion. He will also be one of the strangest scientists of all time. Perhaps no scientist has ever worked so hard without regard for food, sleep, or human relations as Isaac Newton.
Isaac Newton was a much darker figure. He was a loner. He was pathologically incapable of small talk.
We would use the term obsession. I would say he's the closest example I can think of someone who was consumed by his work.
He may also be the greatest scientist of all time. When he is born, the physical world is barely understood. Yet by the time he dies, he's worked out the precise laws that describe all motion, from the fall of an apple to the orbits of planets.
There just hasn't been another human being we know of quite like Newton.
In 1642, Isaac Newton is born in a remote English village. His childhood is an unhappy one. His father dies before he's born, and when he is just 3, his mother farms him out to a stern Puritan grandmother.
When his mother remarried and left him with his grandmother, Newton felt betrayed and isolated, and I think he never quite got over that.
He will later write that his childhood sins included threatening to burn his mother and stepfather in their house. Newton does not always do well in school, but he becomes a curiosity in his village for building extraordinary mechanical devices such as windmills. A schoolmaster convinces his mother to send him to university. At Trinity College, Cambridge, most students drink and carouse more than they study. Newton prefers to be isolated and alone.
Here, looking around him, were a lot of people who had not the least interest in books, who came from well-off families. He must have felt terribly out of place. And also, I suspect, knowing the way that students work, he must have been regarded as an oddball.
Newton, a Puritan, is obsessed with sin. He adopts strict emotional and sexual limits and lives a reclusive, monk-like existence.
Newton was so different from Galileo because Newton was one of the most private people that you would ever know about.
He didn't take pains to make friends, and somehow he didn't relate easily to people. He just pulled back from them.
Throughout his entire life, he has no love affairs and few friends. Some scholars speculate that Newton was homosexual. Others, that he simply decides he has no time for anything but work. It is believed he dies a virgin. In school, Newton pours all of his passion into his studies. Like Galileo, he's captivated by mathematics. He learns advanced math on his own. And then he begins to create a new mathematics to analyze motion. He invents calculus. Newton is fascinated by the way the sun rises and sets in an unbroken arc.
Newton's brilliant insight was the fact that when objects move, they can be viewed incrementally, piece by piece, tiny little increments at a time. And when you add up this motion, you get beautiful spirals, you get ellipses, you get circles. And just remember that when Isaac Newton was scribbling down all his notes, he was creating calculus at the rate at which freshmen in college learn it.
Had he told anyone, he would have been recognized as the greatest mathematician in Europe. But Newton keeps his discoveries to himself, preferring to work out the details alone. Several years later, at age 24, Newton is living in his mother's house. Here, he has an inspiration that will revolutionize all of physics. He will unlock the mystery of what makes the planets move.
Isaac Newton viewed the world pictorially, geometrically. And one day, while walking down his estate, he saw an apple fall. And then he gazed up and he saw the moon. And then he asked the key question, the question that unlocked the secret of the heavens. If an apple falls, does the moon also fall? And then perhaps one of the greatest flashes of insight, he realized that gravity, which then takes an apple and makes it fall to the earth, is the same force that could grab the moon in the heavens, and make the moon fall around the earth.
While Galileo began the study of how gravity acts on Earth, Newton is the first to recognize that gravity also moves the planets and stars.
This was an absolutely world-shaking change. Newton essentially showed that the laws of the heavens were the same as the laws down here on Earth.
But when he tries to work out the details, the complex mathematics eludes him. He will keep his great breakthrough to himself for almost 20 years. Newton soon becomes a professor of mathematics at Cambridge University. With few teaching responsibilities, he works on math and physics around the clock. His colleagues will soon recognize his brilliance, as well as his prickly and strange nature. In 1672, Newton's invention of a new telescope wins him admission to the Royal Society, England's association of greatest scientists. Flattered, Newton allows them to publish a brilliant paper on optics. But when the great physicist, Robert Hooke, erroneously challenges his theory, Newton flies into a rage and threatens to withdraw from the Royal Society.
His reaction to criticism is almost always to carefully explain why what the other person has just said is out and out foolish.
He was an extraordinarily fragile personality. As one of his biographers had said, his motto is rule or sulk, and he spent a lot of time sulking.
Some historians speculate that Newton's vindictiveness, inordinate sensitivity to criticism, and obsessive work reveal symptoms of a mental illness such as manic depression. We will never know. If he does have a mental illness, it does not slow him down. At the age of 42, Newton is asked to solve a problem that is baffling England's greatest physicists. What mathematics describes the orbit of planets around the sun? Seized by inspiration, Newton shuts his door and begins work on his greatest masterpiece. Like Galileo, he is guided by strong intuition. Now, he sets out to crack the complex mathematics of gravity that he began years earlier. For almost 2 years, he communicates with almost no one. His only form of exercise is pacing.
He would sleep very little, that he would work 18, 20 hours a day, that he would skip meals and simply write.
He had the power to sit in his chair undistracted, focusing, obsessed with one problem for years at a time until it finally cracked.
At last, Newton reemerges with a masterpiece that will change the world. The Principia. A ruthless simplifier, Newton strikes at the fundamentals. He uncovers how mass interacts with force, inertia, and acceleration. But his greatest insight is to define gravity. He is the first to call gravity a force acting at a distance. And through breathtaking mathematical breakthroughs, Newton lays out the precise laws that determine the motion of all objects.
Newton's Principia, published in 1687, was a scientific revolution. In it, Newton gave the first precise description of the laws that govern the motion of bodies, from cannonballs to planets.
When you look at the Principia and the number of mathematical problems solved in it, doing that in an 18-month period, this is not a normal human being in any sense of the word.
Newton has completed Galileo's quest to mathematize motion. But over 200 years later, another arrogant rebel will discover that at very high speeds, Newton's laws fail, and the universe is stranger than anyone ever imagined. At the age of 16, Albert Einstein asks a simple question. What would happen if he ran as fast as a wave of light? Would the light wave appear to stand still? When he returns to this image less than 10 years later, he will revolutionize our understanding of space and time.
He loved to imagine worlds that didn't exist. That was his power. The power that he could see things physically in a picture, things that other people couldn't see.
The man who makes these breakthroughs is an absent-minded professor, a twinkle-eyed lover of humanity. But he's also selfish, has 2 failed marriages, and confesses himself an emotional failure. Albert Einstein is born in 1879 in southern Germany to middle-class Jewish parents. As a child, he is quiet and withdrawn.
His parents began to think maybe he was retarded because it took so long before he began to speak. But he was just busy thinking, apparently.
As a young boy, he is fascinated by puzzles and games and shows remarkable perseverance. At age 9, he builds a tower of cards 14 stories high.
By all accounts, Einstein as a child was a nerd. And as a consequence, the other kids would make fun of him. He was apart. He lived in the world of books, the world of ideas.
In 1896, the 17-year-old Einstein wins admission to the ETH, the MIT of Switzerland. Like Galileo, he is witty and sharp, with a sense of humor, and is also a rebel. Einstein has resolved to become a theoretical physicist, but he feels stymied. His physics professor, Herr Weber, has no interest in the latest cutting-edge theories of light and electricity. He passes his exams only by borrowing a friend's class notes and graduates with unexceptional grades. His behavior has not gone unnoticed. All of Einstein's applications for jobs at universities are rejected.
After Einstein graduated from the university, he became a loser in every sense of the word. His professor, Weber, actively disliked the young Einstein. He wrote letters of recommendation, which we now know undermined his chance at any kind of academic appointment. Even before he became a physicist, his life as a physicist was over.
Two years after leaving university, Einstein finally finds a job as a clerk in a Swiss patent office. His work is far removed from theoretical physics, but this seemingly dead-end job will be his salvation. In Bern, the 23-year-old clerk quickly settles into a bourgeois existence. He marries Mileva Maric, a fellow student from the university. Luckily, his job is undemanding enough that he can steal time to grapple with cutting-edge questions in physics, such as the nature of light.
Others in such circumstances would have just thrown in the towel and would have given up on a career in physics. You get the sense that this is someone who just was possessed by an intellectual demon and couldn't do other than what he did.
Now Einstein returns to a simple image he first imagined in high school. What would happen if he ran as fast as a wave of light?
Both Isaac Newton and Einstein shared this uncanny ability to create simple pictures that children could understand and extract from that images which changed the universe.
According to Newton, the speed of a light beam should appear slower to someone who runs alongside it. But light does not seem to obey Newton's laws.
Einstein says the light beam moves away from you at the speed of light, no matter how fast you move. You can never catch up to the light beam. You hit the accelerator, you gun the engine, the light beam still moves away from you at the same rate. How's that possible? How's it possible you can never catch up to a light beam?
Now, like Galileo and Newton before him, Einstein ruthlessly questions assumptions that no one else dares. If the speed of light never changes, then something else must give.
Then he had it. Time is relative. Time is relative to the speed at which you move. And that idea shook the universe.
Einstein has discovered that Newton's laws only hold true for the world of everyday experience. When objects travel at speeds close to the speed of light, common sense breaks down. Distances stretch. And clocks tick more slowly. Newton, forgive me, Einstein writes later. At the age of just 26, he topples Newton's laws of motion with his theory of special relativity. With childlike questions and simple pictures, Einstein changed the world. In 1907, Einstein turns to new scientific challenges. But newly published letters reveal a little-known personal side. As he creates his greatest work, he will withdraw within himself, and those closest to him will suffer. Einstein's wife, Mileva, was once a physics student who dreamed of her own scientific achievements. But now, as Einstein lectures and collaborates with others, Mileva hardly sees him. She fears she is losing both her husband and her dream. Then, in 1914, Mileva discovers that she has a romantic rival, Elsa Lowenthal, Einstein's cousin. Einstein's marriage falls apart.
You know, I'd love to have a beer with Einstein, but I wouldn't introduce him to my sister. There was a sense where the rules didn't necessarily have to apply to him.
Einstein will marry Elsa, who's willing to keep house for him with fewer expectations. He's given up on love in marriage. His science comes before all else. By age 35, Einstein is pursuing a goal many physicists believe is impossible. His intuition tells him that there must be a more general theory of relativity that also explains the force of gravity. Like Newton, Einstein is obsessed. For years, he grapples with mathematics of horrendous complexity, unsure whether he is on the right path or a fool's errand.
He famously would worry a problem for years on end, almost like a dog with a bone. Wouldn't let go of the problem.
When he was working out general relativity, he almost had a nervous breakdown. He would concentrate to the point that he lost an enormous amount of weight. He wouldn't eat. He focused on a problem the same way that Isaac Newton focused on a problem.
At last, in the fall of 1915, Einstein realizes he's solved it. His great insight is so strange, even physicists will struggle to comprehend it. he proves mathematically that mass and energy curve space and time. A massive object like the sun warps space and time so much that a nearby planet moves in a curved path around it. To Newton, they appeared to be attracted by a force. But this is just an illusion. The same phenomena holds true on Earth. Objects that appear to be pulled by a gravitational force are actually traveling through warped space-time.
Einstein's general theory of relativity changed forever our ideas about space and time. It is so beautiful, it has to be right.
Einstein arrives at a set of equations governing space-time curvature. These simple lines describe the motion of galaxies and the destiny of the universe.
When we physicists look at the equations of Albert Einstein, we cry. We cry because they are so gorgeous. Realize that the motion of the heavens, with all the curves, spaces, and time warps and what have you, can be summarized in an equation about an inch long. That is power. That is incredible. That is beautiful.
Although Einstein will continue working until the day he dies, by the time he is 40, he has completed his greatest work. Galileo applied mathematics to motion. Newton perfected these laws for everyday experience. But Einstein's search for a deeper theory revealed laws that govern the entire universe. Today, another brilliant rebel is searching for an even broader theory. A theory of everything. No living scientist has shaken the foundations of physics like Galileo, Newton, or Einstein. But among those who have advanced cosmology's frontiers is a once lazy student named Stephen Hawking. Today, he holds the same chair in mathematics at Cambridge University as Isaac Newton.
I was born 300 years after the death of Galileo. I hold the same job at Cambridge as Newton did, and I work on Einstein's general theory of relativity. Of the three, I feel closest to Galileo. He followed his nose and was a bit of a rebel.
Stephen Hawking is born in 1942 in Oxford, England. Like Galileo, Newton, and Einstein, as a child, he is fascinated by how things work. Yet at Oxford University, Hawking hardly works at all. Instead, he relies on his extraordinary facility with mathematics to coast through. Hawking spends most of his time socializing and on the river with his rowing team.
By all accounts, Stephen Hawking was not the kind of person destined for greatness.
At college, Stephen was not the hardest of workers. Stephen himself says that in his entire undergraduate period at Oxford, he only worked about 1,000 hours, which is an hour a day on average.
Hawking is bored and apathetic. Nothing seems worth working for. Yet a tragedy is about to strike that will turn a bored intellect into a passionate mind. In 1962, Stephen Hawking has just begun to study cosmology as a graduate student at Cambridge University. But signs of illness are becoming too difficult to ignore. A slight speech impediment, difficulty pouring a beer. Doctors tell Hawking he has ALS, commonly known as Lou Gehrig's disease. The regions of his brain that control motion are wasting away. There is no cure. The 20-year-old student learns that his body will become paralyzed. His breathing muscles will eventually seize up, suffocating him. Doctors say he has just 2 years to live. Hawking falls into a deep depression.
When Stephen was first diagnosed as being ill, he really didn't expect to live more than a year or two, and therefore there didn't seem much point in even completing a PhD.
But inexplicably, his disease progresses more slowly than predicted. He meets Jane Wilde, the woman who will become his wife, and he finds a purpose. I dreamt that I was going to be executed, he writes. I suddenly realized that there are a lot of worthwhile things to do if I were reprieved. Now Hawking begins working hard for the first time in his life, and to his surprise, finds that he likes it. By the early 1970s, Stephen Hawking is a well-established cosmologist. He is also in a wheelchair. Yet he is remarkably stubborn. Nothing will keep him from living a normal life. He has children, he works intensely, and he is about to make a great breakthrough that will extend Einstein's theory in an unexpected direction. Einstein's theory of general relativity predicts the motion of very large objects such as galaxies. But it cannot explain the behavior of the tiniest subatomic particles that are the building blocks of the universe. Their motion is only predicted by a different theory called quantum mechanics. And to the frustration of Einstein and every physicist since, the two theories appear completely incompatible. Yet Hawking is brash enough to tackle the impossible.
When Stephen Hawking was doing his pioneering work, there were two armed camps. They hated each other. They never talked to each other. On one side were the true blue loyalists, the ones who held the flame of Albert Einstein burning bright. On the other camp were the quantum theorists. They dealt with the world of particles, subatomic particles, hundreds of them, thousands of them, and they didn't talk to each other. They had different mathematics, they had a different language, a different physical picture, and here comes Stephen Hawking saying, I'm going to try to marry the two together. Well, that was heresy. No one had done that before.
Now Hawking asks, what happens if you look at a black hole, a massive object, but zoom in to its smallest scale?
Hawking also, like Einstein, has an incredibly good nose. That he has an intuitive feel for interesting questions to ask and how to ask them.
Black holes are the most bizarre and extreme prediction of Einstein's theory of gravity. Theoretically, if a mass is extremely concentrated, for instance, if a star were compressed into a ball just miles wide, the space around it will become so warped that gravity will keep everything from escaping, including light.
A black hole is a region of space in which gravity is so strong that light can never escape. It's like a one-way membrane in which things can go in but nothing ever comes out, including light, and that's why it's called black.
Now Hawking attempts something his colleagues assume is impossible. He uses the equations of quantum theory to analyze what happens to tiny particles trapped by gravity on the edges of black holes. by now, he can no longer write. If he was an experimentalist, his career would long be over. But Hawking has rarely even looked through a telescope. And for theory, all he needs is his brain. Like Newton and Einstein, Hawking has great powers of concentration. He reruns long, torturous equations again and again in his head, checking and rechecking his calculations.
He tends to think in pictures, and he tends to start with some idea that he thinks he is right, and he goes from there.
He has to rely upon keen insight and leaps of logic to compensate for the fact that he cannot check every single line.
He just has a tremendous drive, a tremendous determination to get to the bottom of things.
Hawking's results shock him. Black holes are not completely cut off from the rest of the universe as once believed. Instead, their edges shed tiny particles, now called Hawking radiation.
The arguments are so compelling, everyone now agrees that black holes must give off Hawking radiation. The radiation will carry away energy and mass, and the black holes will slowly evaporate and eventually disappear.
Hawking has shown that like water in a boiling kettle, black holes slowly evaporate away. Just as importantly, he's proven that in one particular case, general relativity and quantum theory can be fruitfully combined.
My discovery that black holes are not completely black, but should glow like hot bodies, was the first example of an effect that depended on both the large and small scale theories.
When the result came out, it was so beautiful. It just had that feel about it. Just talking about it was like rolling candy on the tongue.
Finding a theory of everything, a deeper theory that unifies Einstein's equations and quantum mechanics, is now the holy grail of physics. It would explain the origin of the universe. And Hawking has created new hope that this ultimate puzzle can be solved.
It's clear that Stephen's discovery of black hole radiance was an important piece of the final jigsaw, even though we don't really know what the final jigsaw is yet.
Who were the greatest physicists? They were ugly ducklings, rebels, and nerds, consumed by deep intuition and unafraid to question the most basic assumptions.
It does take a strong ego to say, well, that's not so tough, I can crack that. I mean, the odds are really against you. There's no guarantee that there are any answers out there, that science actually works. You're really taking a huge chance.
Their stubborn persistence revealed deep laws of nature, but their quest remains unfinished. And such brilliant minds come along only once in a great while. Yet who knows? It's possible that the next brilliant rebel is already among us. They are misfits, arrogant rebels. They scorned conventional wisdom, and each conceived a radical new vision of the cosmos. Galileo Galilei, Isaac Newton, Albert Einstein, and Stephen Hawking have all had tumultuous lives, filled with great triumphs and humbling failures.
These are the people who would dare to challenge.
They often run into opposition, and they generally don't deal very well with that.
There was a kind of a demon within them that wouldn't let them do anything else.
It does take a strong ego to say, well, I can solve this. I can figure out some little piece of the universe.
Who were these brilliant rebels? And what secrets of their minds allowed them to think the unthinkable and reveal the beauty and strangeness of the universe? In 16th century Europe, life has a certainty that later generations can only envy. Everyone knows that the Earth is the center of the universe. But this reassuring
Philosophy, for example, objects moved and came to rest, not because of friction, but because they got tired. And objects fell to the ground, not because of gravity, but because they longed to be united with the Earth.
To Galileo, such explanations seem absurd. These grand personages who set out to discover the great truth and never quite find it give me a pain, he later writes. They can't find it because they're always looking in the wrong place. Now, Galileo is about to shatter thousands of years of belief. His intuition tells him that objects move, not because of desires, but because of deep mathematical laws. And his unthinkable step is to find them through experiments, something few people have done before. He begins by studying falling bodies. Physicist Stephen Hawking.
Galileo pointed out that simple observations, like dropping weights from a height, show things do not work the way the ancient Greeks said. This must have been seen by many people, but they had put it down to imperfect observation.
Vision is beginning to crack. And one of those who does the most to overturn it is a self-styled genius, Galileo Galilei.
Galileo, of course, was this cocky individual who had an attitude.
The sort of person who makes very close friends and who makes lots of enemies.
But he had a very sharp wit, a very sharp mind, and with that he was able to probe some of the deep mysteries of the universe.
This ambitious, overconfident scientist will remake the world, but pay a harsh price. Galileo is born in 1564 in Pisa, Italy. His father, a lute player, is well known for rejecting convention to create a new form of musical harmony. Galileo inherits his father's rebelliousness. At age 25, he becomes a professor of mathematics at the University of Pisa. But he'll grow scornful of his colleagues, who are still teaching the scientific theories of the Greek philosopher Aristotle, almost 2,000 years after his death.
We forget the fact that before Galileo, there really was no science as we know it. According to the Aristotelian
Patience.
For the first time ever, Galileo begins to work out basic laws of motion, such as how speed is determined by time and acceleration.
It was one of the geniuses of Galileo to slow down the acceleration of gravity. He got an inclined plane and had a ball roll down the plane, and then you could see with your own eyes the fact that an object speeded up as it went down. So he introduced the concept of acceleration.
To us, that seems so obvious and logical. That was a major mathematical breakthrough to understand motion in those terms.
For his role as the first experimenter, Albert Einstein will later call him the father of modern physics. Galileo has pioneered the path that Newton and Einstein will follow. The search for mathematical laws that lie behind all motion. But progress is slow. Only at the end of his life will they finally be published. At age 45, Galileo is still a poorly paid mathematician. But ambitiousness and arrogance will soon catapult him to fame and be his undoing. In 1609, Galileo hears rumors of a toy-like spyglass that makes distant objects appear near. Resolving to capitalize on it, he quickly learns to grind lenses. Within a few weeks, he arrives in Venice with a telescope he champions as his own invention. He impresses Venice's navy so much that officials double his salary.
Galileo did not bother to tell them that this was an instrument that was being exhibited and sold in many other places. There was considerable chagrin when they discovered that, in fact, this was not Galileo's unique invention. Well, what can you say? He was obviously being a good businessman there.
To the free-thinking Galileo, the telescope also offers an opportunity to ask questions few others dare. 60 years earlier, the astronomer Copernicus proposed the radical idea that the Earth revolves around the Sun. But Copernicus had little evidence for his theory, and it contradicts passages in the Bible. In the time of the Inquisition, such speculation